yesterday we talked about end behavior. So basically the directions that the arrows were pointing. And we use this fancy notation for describing that. We use limit notation. All that means is you're going to have this notation. When you see x approaches negative infinity, we know that means it goes to the left. What's happening to the y's? If the arrow points up, you put a infinity. If the arrow points down, you put a negative infinity. Something else we're going to talk about that's really important about these graphs are what we call turning points. So a turning point is where the polynomial changes direction. So if you were to trace the graph, your finger is going to go up, and then it's going to go down, and then up, and then down. So those specific points where it changes, those are your turning points. If the turning point is higher than a nearby, like if it's a hilltop, we call it a relative maximum. And we'll really just use max. There is such thing as an absolute max and an absolute minimum. We're not dealing with that in here. So just max and min is okay. You don't have to specify. But if it's a hilltop, it's a maximum. If it's a lower point, so if it's a valley point, we call it a relative minimum. Now, the only way that you're going to figure out these points are from the calculator. And the TI-84s, they have a way to get that exact point, to get a more precise point. It's kind of long. There's another way that I've outlined here. Let me show you. I'm just going to pull up an example. Y equals x squared minus 1. I don't even know if this will show up. Okay, good. Alright. So the trace button, if you hit the trace button, it'll put like a little dot and you can trace the graph and you can get to these hilltops and valleys. The problem is that point isn't officially the exact point. Like it's close, but it might be rounded off. The Desmos calculator, you can click. You know how we did with quadratics? We clicked on the vertex. It gave us that exact vertex. That's what we're going to do with these. It'll be more precise. I think it's more user-friendly because all you got to do is click on it. All right, so that's what we're going to use in here. But if for some reason you just had the 84, you graph it, you hit the trace button, and you just trace through it. But we're going to do Desmos. So number 9. We have y equals, it says f of x, but in Desmos, y equals negative. And the good thing about Desmos, again, is that there's no separate minus and negative button. You use the same minus for both. So negative x, it is a little harder to do on the phone, x to the 4th plus 4x squared minus 2x minus 1. And when I zoom in, right, I can click and I can find lots of important points on Desmos really quickly. You can see there's some points where it crosses the x-axis. We will officially get into that later, but you can find those, and you can find these hilltops and valleys. So what we're going to do is we're going to sketch out the graph, just a very quick basic sketch of this graph, and it looks something like this. So any point that's kind of on a hilltop, a mountaintop. So that would be this point. I forgot my green doesn't work. This point and this top. Those are your hilltop. Those are your maximums. And then the valley points are considered your minimums. So all I have to do over here on Desmos is just click and I get that maximum. So I'm going to just list out the points over here. Negative 1.526, 5.994. That is one of the maximums. And then the other maximum is the point 1.267, 0.31. So easy to find those. And then we have one minimum. Now be careful, like if you look here, when I click on this, notice there's several different points that are clicked. That's got a little point on them. I don't know if you can see that. It'll be the same on your Chromebook. But like it's going to put a point on any x-intercepts. It's going to put a point on the y-intercept. So just make sure you've clicked on the right one. Notice I want the one that's like truly down here in the valley. That's the true minimum. Okay. So it's 0.259, negative 1.254. Let me show you this exact same problem in the TI-84s and show you how it's a little different. So graph it. And I hit the trace button. It's like if I go up here to a max, I have negative 1.515. Like I never truly get that number. It's close, but it's not going to be the most precise. Now there is a way to get the precise point, but it's really complicated in here. I don't even want to show you and confuse you. Just use the Desmos one. Okay, it'll be a lot easier. Alright, let's do number 10 together, and then I'll let you do 11 and 12 on your Chromebooks. Alright, so y equals x cubed plus 2x squared minus 4x minus 1. I will say zooming in and scrolling around on the graph is easier to do on your phone than on your Chromebook. So I'm just going to sketch it out. How many maximums does this graph have? One. How many minimums? One. Yep. So if I click this, I have a maximum at negative 2.7. And then the minimum is not a nice neat point. before you go on, let's tell me about the end behavior of number 10. So what's happening on the left? The y values are going down. What's happening on the right? The y values are going up. So if I was going to write this out using limit notation, here's what I would say. The limit as x approaches negative infinity. So the limit, so as x approaches negative infinity, your x is going this way. Your y values are approaching what? Negative infinity. If the y values are going down, we put negative infinity there. Then I would say, okay, the limit as x approaches positive infinity. So as I go to the right, the y values are approaching positive infinity because they're going up. Yeah. All right, do numbers 11 and 12. Find the max and mins. Use Desmos.
Mr. Cope's test.
Look up here, see if your max and mins match what I have.
Yep, they're right on yours.
Perfect. All right. Any questions?
That's light work.
All right.